Hello everyone, I welcome you all for the lecture 2 Geospatial Science and Technology, and this presentation is on behalf of Center of Excellence in Land Administration and Management, and which is an initiative of DILRMP, Department of Land Resource, Ministry of Rural Development, Government of India, which is currently at the Administrative Training Institute, Government of Karnataka, Mysore. So in the last lecture one, we have discussed about the introduction of GIS and how it is applicable in land administration and management, and we also seen the broader perspective of the GIS. So in this particular lecture too, we are mainly concentrating on the geospatial science and technology, and what are all the technologies that are all involved in mapping of geographical areas, geographical space, and how all technologies are used in an integrative manner in order to bring the better decision and to implement the policies. So if we look into the definition of the geospatial science and technology, the geospatial technologies is a term used to describe the range of modern tools, right? So this is not a one or two tools, we have a range of modern tools, collective tools, which is contributing to geographic mapping and spatial analysis of the earth and human societies. GIS is not only used to study the natural features of the earth, but it is also used to study the socio-economic aspects of the earth too. So that means through the geospatial science and technology, we are going to study the human and environment interaction, how both will evolve, how both will emerge, and how it changes from one place to another place. So these are all the things we are going to study with the help of geospatial science and technologies. So all the technologies, so it can be anything, so all the technologies that are used to acquire, manipulate and store geographic information collectively together to be called as geospatial technology. So why geospatial science and why geospatial technology, science and technology both together to be called? Why? Because the geospatial science talks about the pure nature of the geography, and the technology, the modern tools that are going to helpful for us for the mapping of the earth and as well as the human society. So that's what it is, both science and it is both technology. So let us see what all the technologies are there within geospatial technologies. So one thing is the GIS, Geographical Information System, that is one of the tool, and we have one more technology that is called remote sensing. So we will discuss in detail regarding these technologies in the upcoming slides. So remote sensing, so surveying, GNSS, RNSS, Global Navigation Satellite System, Regional Navigation Satellite System, UAVs, Unmanned Aerial Vehicle, LIDAR, Light Detection and Ranging, BIM, Building Information Modeling, Photogrammetry, Cartography, IoT, Internet of Things, AI, Artificial Intelligence, Cloud Computing, Data Analytics, Deep Learning, and other. So there are a lot of technologies are collectively used for geographical mapping. So if we look into the developmental stages of the GIS has initiated by the English Canadian geographer who is called Dr. Roger Tomlinson, who called to be as the father of GIS, right. So the Roger Tomlinson is called as father of GIS because he pioneered the development of first computerized geographic information system in 1960s. So before 1960s there were a traditional form of mapping where hand-drawn, handwritten maps were used, but Dr. Roger Tomlinson introduced the concept of computerized mapping in 1960s, and his work laid the foundation for modern GIS technology. So, what are the key contribution by the Dr. Roger Tomlinson is? So, he has developed the first GIS, that is called Canadian Geographic Information System, to manage the land use data for the Canadian government in 1960s, and also he introduced the digital mapping. So, before GIS maps were paper based, Tomlinson system stored and analyzed the spatial data digitally, and pioneered the GIS concept. So, he established the fundamental GIS principle, including the layer based spatial analysis, which is still being used. So, layer based spatial analysis means, so particular event, particular layers will be used. For example, a temperature layer, the humidity layer, a built up layer, a park layer, road layer, tree layer. So, a number of layers can be created and it can be overlaid one on another in order to perform the spatial analysis, like to study how one particular geographic feature impacting the other geographical feature, to study the correlation between one or more two or more layers. So, then these type of layer based spatial analysis will be helpful, and till today we are using the layer based spatial analysis in order to identify the uh, cause and consequences of a particular area, and why the particular phenomena is triggered, and what are all the driving forces. You can take the example of the flood in Bangalore city. So, why the flood has happened, so what mainly causing the flood. So, these kind of analysis that can be done through layer based spatial analysis. And the fourth one is the promoted GIS for decision making. So, he laid a foundation for the decision making through the GIS, and his work, that is especially the Canadian GIS Geographic Information System, demonstrated how GIS could be applied to resource management, urban planning, and even for the environmental studies. So, these are things, and also he authored the book called Thinking About GIS, so which influenced the generations of GIS professionals across the worldwide. So, that's what Dr. Roger Tomlinson is called as the father of GIS. Okay, so we will see the different technologies one by one in detail, and we'll get the idea about it before proceeding into the detailed aspects of the geospatial science or the geospatial technology. So, these are all the things. Okay. So, the GIS, so in the lecture 1 itself we discussed about this GIS, geographic information, and both geography and information are tagged together within one system, and this system going to helpful for us to study the changes happening around the world, right. Then the next technology that is being used in geospatial science and technology is the remote sensing. So, remote sensing in general, if we say the remotely sensing the information without being in a physical contact, let us say the example of the TV and the remote. So, we can able to turn on turn off the TV using the remote. So, it is nothing but the remote sensing in general. But if we specifically look into the geospatial science and technology, we use different instruments or a uh, different instruments like a drone, like aircraft, like satellites through which flies aerially to collect the imageries. Okay, so let's look into the definition of it. Okay, remote sensing is a process of gathering information about an area or an object from a distance. So that means there is no physical contact between the sensors and the particular target. Target is nothing but the earth surface, where we are collecting the information about the earth surface aerially by using the sensors. The sensors will collect the reflected or emitted energy from the object. So, majority of the photosynthesis activity for the earth, which will happen through the help of the sunlight travels and reaches the earth, and we will get the energy in the form of radiations, and those radiations are helpful to discriminate what type of feature by the sensor. So if there is no illumination, if there is no source of energy, then we cannot able to see anything. So likewise, through the help of illuminated energy from the sun, we can able to gather the information about the earth through the help of remote sensing satellite and the sensors which is mounted to the satellites. So these are all the examples. So we classify these remote sensing technology according to the height of data acquisition, whether it is a ground based or whether it is a air based or space based. Ground based means you have a handled instrument to collect the information about a particular object. Let's say the example of spectrometer, where we use the spectrometers to study the spectral reflectance and its characteristics about the plant, to discriminate the health and other properties. And if you fly a drone or if you fly a aircraft, then that will become airborne remote sensing, aerial we are flying. And since we use satellites, then it will become a space-borne remote sensing. So ultimately the remote sensing is nothing but the collection of data about the earth without being in a physical contact, and capturing those information, and based on the information we can able to extract the meaningful information out of it. Then the next technology is the surveying. The surveying is a technique of determining the relative position of the different features on or above or beneath the surface of the earth by means of direct or indirect measurements, and finally representing them on a sheet of paper known as plan or map. So we use different survey instruments in order to measure the shape, size and dimension of the earth and earth features. So during the survey, so those who do a survey, they called to be as a surveyors. Surveyors use the traditional and modern tools to do their job successfully and accurately, such as total station, which is classified under EDM device. EDM means electronic distance measurement, and GPS global positioning system in order to receive the position, and prisms, 3D scanners, radio communicators, digital levels, dumpy level surveying software. So majority of that tools being used for surveying the land features. So these are all the instruments where in the traditional form of surveying, the chains, plane table, ranging rods were used. But if we look into the modern surveying instruments, so the total station, theodolites, DGPS, these are all the instrument which is acting as a tool, which is acting as an instrument for measuring the earth surfaces and what are the features available in the earth. Then another technology that is being used in the geospatial science and technology is the GNSS, Global Navigation Satellite System. So this particular global navigation satellite system is used to determine the position of the user with the reference to some particular point. Let's say in the with respect to the earth, we have a two reference line. One is the equator and another one is the prime meridian as a reference line. So from the equator, at what degree of deviation that particular user is standing, and at what degree of deviation that particular user is standing from either east or west from the meridian. So based on these we can able to determine the coordinate of the user. So the coordinate will be in the form of latitudes and longitude, and also the altitudes. So all the information will be captured with the help of GNSS system. So this GNSS system global, we call that as a global navigation satellite system. Why? Because these systems covers the entire world and we have a worldwide coverage. So wherever you are, whether you are in an equatorial region, or whether you are in a north pole, or whether in a south pole, you can be in anywhere. So your position can be easily determined through the help of these satellite systems, if you have a GPS, that the signal receivers, right. So we also call that as which is mainly used for the PNT services. PNT means positioning. So we can able to determine the user's position with respect to latitude and longitude, and navigation. So that means the mobility aspects. If the particular person is moving from one place to another place, then the continuous information about the navigation can be acquired seamlessly, and the time between one particular point to another particular point, and based on the difference between the two different points where the user is moving. So based on that, we can easily able to find the speed and velocity of the particular person who is traveling, or can take the vehicle too as an example. So GNSS is one of the wonderful technology till date for different location based services. So day to day also we are using the GPS with knowing or without knowing. Google Maps uses the GPS, where you used to travel from one place to another place with the help of these systems. And majority of the delivery systems like Zomato, like a Swiggy, like a Uber, Ola. So all these apps uses a GPS, where you can able to determine your own location and the facility provider location. So we also call this as last mile connectivity applications, where the GPS will be helpful for accessing the location of any users. So how this particular GNSS works? So if we look into the GNSS, it uses a constellation of satellites. So constellation means the satellites are arranged in a certain manner to cover the entire world. And the GNSS uses satellite signals to determine the distance between the satellite and the receiver on the ground. So this GNSS satellite continuously broadcasts the radio signals, so 24 into 7 without any limitation. Then the user has to receive the signals. Once the receiver received the signal, then the difference in signal between the time taken to travel between the satellite and to the receiver will be calculated. So that is the differencing in the signal. Then that difference will be multiplied with the speed of light. Then we can able to determine the position of the user from the satellite to the user. So likewise, from the multiple satellites, multiple signals will be received, and all the signals will be triangulated, and based on the triangulation method, the device will determine the position, so the latitude longitude of a particular device, right. So GNSS is a key part of communication, navigation and surveillance, and also the infrastructure. So these GPS or GNSS mainly developed for the military applications initially. Later on, it become for used for the civilian use. If we look into the GNSS systems, different countries operating the different systems, like one of the early system is the GPS global positioning system, which is by the USA, and which is operating since 1978. So currently there are 31 satellites are constellated in a orbit. Then if we look into the GLONASS, that is Global Navigation Satellite System, which is by Russia. Russia also launched these GNSS systems, where it contains the 24 satellites to cover the entire world. And European Union also launched the system called Galileo by the European Space Agency in the year 2016, and which is also a constellation of 30 satellites. China also developed the GNSS, which is called Baidu Navigation Satellite System, and which is around 45 satellite systems are there. So these number of satellites are forming a constellation in a space in an orbit, and if the receiver is designed to receive the signals from all these satellites, means then we can able to attain the more accurate positions. Even the centimeter grade position accuracy can be attained. Even the small stone on the ground can be mapped if our receiver having the capability to receive the signals from majority of the GNSS providers. If you look into the another term that compensates the GNSS is the RNSS, Regional Navigation Satellite System. As compared with the Global Navigation Satellite System, a Global Navigation Satellite System is a constellation which covers the entire world. But if we look into the RNSS, the Regional Navigation Satellite System, which covers certain regions only, but it will not cover the entire world. Why? Because some of the technologies are developed by different countries or different regions. Especially in India, we have a system called Gagan, GPS aided geo augmented navigation, currently which is operated by the ISRO and Airport Authority of India. So what this RNSS does is, RNSS having the satellites, a limited number of satellites which covers the particular region. Especially the Gagan, we have 7 satellites which is operating since 2013 in order to increase the efficiency of internal aviation and the internal military purpose. So you can ask the question like, why RNSS are developed when we have GNSS. So since it is GNSS, it is funded by public money, and there is one concept in GPS that is called selective availability. Suppose if any war declares in future, hypothetically, then the US region, USA or Russia may turn off the systems. So if the systems are turned off, our systems are made not available for the other countries, then what are all the countries depending on these systems will become hampered. And those if we take the example of the India, if India is completely dependent on the GPS, if based on the selective availability, if US turns off the GPS, then what happens is, the what are all the military equipments that is equipped with the GPS system will go unusable. So that's what every country should have their own RNSS. So in that race, the India also developed the Gagan, and in the Gagan, the India have its own GPS, that is positioning system for internal aviation and military, and also it will be available to the public in near future, and the integrated circuits are being developed for the mobile application as well. So similarly, different countries have their own regional navigation systems, like North America having WAAS. Even though they have a GPS, they have one more regional navigation satellite system that is called Wide Area Augmentation System for their internal aviation and the military applications, like IGNOS from the Europe, MSAS from the Japan, right? Sorry, it's replicated, and SDCM, that is system for differential correction and monitoring by Russia, and Baidu for the China, right? Apart from the GPS, we have one more technology that is being used in the geospatial science and technology, and as well as the land surveying and mapping application, is the use of UAV, unmanned aerial vehicle. See, unmanned aerial vehicle, commonly known as drones, which are the aircraft operated without a human pilot on board. They are used for variety of applications, including the surveillance, mapping and disaster management, agriculture, logistic and so on. So lot of applications are there. The very few applications I have listed here, right? The drones. So normally we are using that. So drones also having a different types that we will discuss in the upcoming lecture series. And one more term that we use in the geospatial science and technology is the UAS, unmanned aerial system or unmanned aircraft system. So what this is, in UAV the drone exclusively to be called as a UAV, but in UAS the remote, the antenna, the uplink, the downlink, and the entire system that is collectively to be called as UAS, including the operator of the particular drone. Everything will come under the UAS. So once the drone is flown over the area, then a series of images will be captured, and through the series of image then we can able to reconstruct the ortho generated images of a particular area. Then we will get a end product. That product we call as a ORIs and the DTM or a DSM, digital surface model, where the height of the buildings also can be studied through the help of this, and through this we can able to generate the contour, the height information about the geographical feature. All these things can be beneficial for the land administration and management. And one more technology which is being used in the geospatial science and technology is the reality modeling. So in the reality modeling is, so we are bringing the virtual information about the earth in a computer system. So in reality, whatever we are able to see through our eye, so the same in detailed information that can be brought to the computer system by creating the reality models. These reality models are based on the concept of photogrammetry, so photogrammetry as well as lidar. So fusion of multi-sourced data, we can able to create a 3D model of the particular landscape. So once the landscape 3D model is created, we can perform a different types of analysis where the height of the building can be measured, and the line of sight from one place to another place can be measured, and altitudinal information can be measured. So everything in detail we can able to study when we have a reality model of a particular study. And the main drawback of the reality modeling is the resource, the time, and the hardware capability should be very high while creating reality models. So more sophisticated instruments is required in order to create a reality models. If you look into that, cameras, drones, laser scanners, lidar equipments, all we can use to create the reality models. So ultimately we have to represent the entire world in 3D and also in the computer systems. So these are all the 3D models which is generated through the reality models. The 3D scene can be generated. And one more technology which is under the geospatial science and technology is the LiDAR, so light detection and ranging. So it is also one of the EDM instrument, electronic distance measurement. So if we look into the total station is a single beam EDM. That is, a single beam is sent from the base to prism and prism to base. The distance between the base and the prism is mentioned. But if we look into the lidar is a multi-beam EDM. So multi-beam means multiple beams are penetrated in a 180-degree manner, then all the reflected energy will be captured. And one of the advantage of the lidar is it will penetrate the leaves also. So even the dense forest can be mapped, and the altitudinal information can be mapped if we go with the lidar. So but if we look into the satellite imagery, through the satellite imagery we cannot able to see what is beneath in the dense forest. We cannot able to see the floor of the dense forest. But if we utilize the technology like a lidar, through the lidar we can able to see what inside the dense forest. And why? Because it will penetrate through the leaves according to the strength of the lidar data, the lidar light energy that we are penetrating from the sensor. So this is one of the example where the aircraft is mounted with the lidar sensor, and lidar sensor is scanning crosswise, and the data is being collected. So what type of data it will collect means, it will collect the point clouds. A series of points will be collected. Those points will represent the dimension and shape of the particular area. So one of the great breakthrough of the lidar technology is the archaeologists revealed the layout of Angkor Wat and nearby structures underneath the jungle foliage, Cambodia, Empire, so which is buried in the year 20th, 12th century. So that means almost 800 years, the particular Angkor Wat were buried, but with the help of LiDAR, the hidden structures are identified, and the entire dense jungle were cleared out. Now this particular Angkor Wat is made available for the public to visit. So this is one of the great discoveries. This is one of the example in the archaeology, but majority of the applications are need to be explored. And one more technology is the BIM, so building information modeling, where BIM concentrates on the building and building floors, the number of steps, number of doors, number of windows, everything is modeled in a 3D, and we can able to visualize everything by taking the sections and by looking into the different dimensions, by looking into the different angles of the data. So each and individual minute details can be mapped, including where is the wall, where is the sofa, where is the curtains. All the information can be easily brought under the BIM concept. As I said that the photogrammetry is through the help of series of photographs which is captured over an area, and the similarity between one photograph to another photograph will be reconstructed, and through this the 3D model of the particular landscape can be modeled, and through this 3D model we can able to extract the linear aspect, aerial aspect, and also the volumetric aspects can be extracted through the help of the photogrammetry. So in photogrammetry we have two types of technology. One is the aerial photogrammetry, if the photograph captured aerially, and we have one more concept called terrestrial photogrammetry, where the photographs are not taken aerially but terrestrially. These terrestrial photographs will help us to create a 3D model of any features. We call this as a close ranged photogrammetry as well. And one more science or a technology you can call both together, as that is the cartography. So ultimately we are going to use the cartography for the compilation of the maps. So whatever the land survey we do, ultimately we will bring in the form of plans, we will bring in the form of maps. So these maps will be beneficial for us for in order to document the geographical properties of a particular area. As I said in the lecture 1, that Survey of India having the topo sheet which they have mapped the entire India at the 1:50,000 scale, and in the year 1970s all the informations are clearly made available for the interpretation. So we can use these type of compiled map in future. Let's if for example if we document the current availability of the geographical features. So the geographical feature will change obviously from one year to another year. So in 1970s whatever the features are there, the Survey of India has mapped. So if the Survey of India committed again to map the entire India, means the one more data will be made available. In next 50 years the future generations can use these kind of data in order to study how the feature was earlier in the current year and how the feature was earlier in 1970, like that. So the comparative assessment can be done how the particular place has evolved from one year to another year. So the maps are the ultimate ultimate step where we bring all the data into the document. So this ends the lecture 2, and we will see many more information in the upcoming lecture series. So thank you everyone. Please visit us and we follow us at the Instagram, YouTube, LinkedIn, and write us through our Gmail if you have any questions, queries, or if you have any innovative ideas, you can write us, and can collaborate with that. Thank you. So by this I am ending my lecture. Thank you everyone.